Hello friends, welcome to Life with YouTube channel. So today we are going to discuss about new topic in maths which will be easily understand to you. So and the topic is matrix. Okay, so please take a notebook and pen, be ready and sit in a room which is pleasant and keep your mind pleasant and listen this. Okay. So today we're going to discuss about matrix. Matrix. First of all, before to know about matrix, we should know about who introduced the matrix. Okay, and the person who introduced the matrix is James Sylvester. Okay, James Sylvester, but it was improved by his friend Arthur Coyle. Okay, Arthur Coyle. So he is known as the father of matrices. Okay, so Arthur Coyle is known as the father of matrices. So what is matrix? Matrix. A matrix contains numbers, symbols, or variables, expressions, everything. So a matrix contains numbers, expressions, symbols arranged in rows and columns in closed brackets. Okay, in closed brackets. A matrix contains numbers, symbols, or variables or expressions which are arranged in rows and columns in closed brackets. Okay, you know what is meant by numbers, symbols, and expressions or variables, but you don't know about, I think so, rows and columns. Rows. This is called row. Row 1. Okay, column 1, row 2, column 1 and column 2. Okay, I think so you have understood by this what are rows and columns in closed brackets. So the closed brackets determines, okay, this is the symbol of the brackets. So matrix contains numbers, symbols, expressions arranged in rows and columns in closed brackets. So I'll give you one of the best example. For example, 1, 2, 3, 4, 5, 6, 7, 8. Some people will mention commas, full stops in this matrix. Okay, should not mention all those things. So we can rows and columns. I said, you know how many rows do you have in this? 1, 2. Rows have 2. Columns 1, 2, 3, 4. So now you know about columns. So the numbers or expressions or symbols or variables which are present in the closed brackets are called elements. Okay, these are all called elements. Okay, I think so you have understood what are elements, what are rows, and what are columns. Okay, so please note down this, don't waste your time, and pause the video and note down that. So next we can go to other topic. Okay, the topic is order of the matrices. You know now what is matrix? Now we should find order of the matrix. Okay, order of the matrix. Order of the matrix. So I'll explain you this by taking an example. As I said before, an example 1, 2, 3, 4, 5, 6, 7, 8. So you noted how many rows and columns are there, right? So how many rows do you find in that? 2 rows and columns 4, right? So the order of matrix will be 2 into 4. By this you have understood that the order of matrix will be represented by R into C notation. Okay, note down this, it is very important. R into C notation. Okay, so R, number of rows 2, C, columns, number of columns 4. So 2 into 4. This we should write here, 2 into 4, below the matrix, 2 into 4. And the writing format is 2 into 4 itself, but the reading format is 2 by 4. Okay, you have understood now? 2 by 4. It is reading format. Okay, you have understood now? Order of the matrix should be R into C notation. So here you have 2 into 4 matrix, you will have 1 into 3 or 1 into 2 or 3 into 1, 2 into 2, 3 into 3, 3 into 4 or 4 into 3. There are many types of matrices. So order of matrix here for this example is 2 into 4. I am giving you now one of the question, that is what is the order of the matrix? If you know that, please write the answer in the comment. Okay. So next we can go to other topic, that is types of matrices. There are many types of matrices. Now we can know that one by one. So types of matrices. Types of types of matrices. There are many types of matrices. Let's know it one by one. Okay. First one, square matrix. What is square matrix? A square matrix is in which where the number of rows is equal to number of the columns. You know how many rows, you know how to count them. Okay. So a square matrix where number of rows is equal to number of the columns. Okay. For example, as I said before, running the example, or we can take a new example 1, 4, 5, 2. You know, so how many rows are there? 1, 2. How many columns are there? 2 columns, right? So the order of the matrix will be 2 into 2. Here you can observe the number of rows is equal to number of the columns, right? So therefore this is square matrix. This is 2 into 2 matrix. For example, I'll give you one of the 3 into 3 matrix. 3 into 3. Here also is the same. Number of rows is equal to number of columns. So this is square matrix. Next we can go through rectangular matrix. Rectangular matrix. So by square matrix, you can say what is rectangular matrix. The simple thing I'll say you is the opposite of square matrix is rectangular matrix. So what is square matrix? Number of rows is equal to number of columns. Then the rectangular matrix will be number of rows is not equal to number of columns, right? You have understood. So write it here. Number of rows is not equal to number of columns. Okay. So number of rows is not equal to number of columns. You have understood. So I'll say you one of the best example. Before I have said you 1, 2, 3, 4, 5, 6, 7, 8. So count how many rows and how many columns are there. So first row, second row. So there are 2 rows, columns 1, 2, 3, 4. So there are columns 4. Okay, rows 2 and columns 4. Here what I said, rectangular matrix where number of rows is not equal to number of columns. Here 2 is not equal to 4. Okay, by this is called rectangular matrix. So we can say that rectangular matrix is opposite to square matrix, or square matrix is opposite to rectangular matrix. Okay, next we can go through row matrix. Now please note down this, don't waste your time. This will be very helpful to you in your exams. So row matrix now. Row matrix. What is row matrix? The row matrix is a matrix which contains only one row. In simple way, only one row. It means, as I said, well, how many columns and how many rows you need to count, how you need to count, I have said you. So in that way, I'll give you one of the example, 1, 2, 3. Okay. See, this is one of the example. Count how many rows are there. Only one row. So R equal to 1, and where columns are 3. So column equal to 3. Here, what I say for row matrix, what is the property? It should contain only one row, right? Here the rows number are 1. So the order of the matrix is 1 into 3. By this you can say that the order of the row matrix, especially I am saying you row matrix. So the order of the row matrix is 1 into C notation, where C is called number of columns. Okay, you have understood better, I think so. So note down this, and next we'll go through column matrix. You know column matrix by understanding the row matrix, I think so. Column matrix is nothing but opposite to row matrix now. So a matrix which contains only one column. I'll give you one of the example. 5, 6, 7. Okay. Have observed here 5, 6, 7. 5, 6, 7. Count number of rows and number of columns. 1, 2, 3. 3 rows, 1. So 1 column. So here only one column. We said property should be as only one column. Only one column, right? One column and 3 rows. So here by this we can say the order of the column matrix is row into, R into 1, where R is number of rows. Okay, number of rows. By this we can say that row matrix is very opposite to column matrix. Okay, so note down it. So next, now we can go through null matrix. So now fifth one, I think so. Null matrix. So null matrix is nothing but a matrix which contains 0 in all elements. The all elements should be as 0. That is called as null matrix. I'll say by example 0, 0, 0. Okay, it's a 2 into 2 matrix, but it contains 0 all elements. So this is called null matrix. Okay. Next, we can go through principal diagonal matrix. What is principal diagonal matrix? Say, think. So that is the straight path from first element of first row to the bottom of last element of last row. Have you understood by this? By the definition you can understand it. Okay? The straight path from first element. I'll say you this by an example. But it should, one of the properties, it should be a square matrix. What is maybe the order of the matrix, but it should be a square matrix. I am taking one of the examples, square matrix. 5, 8, 9, 11, 3, 4, 10, 6, 8, 14, 21. So this is a square matrix of 4 into, sorry, 3 into 4, right? 3 into 4 matrix. So it is not a square matrix. Ten, 13, 19, 1. So this is a 4 into 4 matrix, right? 5, 8, 9, 11, 3, 4, 10, 6, 8, 14, 21, 10, 13, 19, 1. So what the principal diagonal matrix is the straight path from first element of first row. This is the first element of first row to the bottom of last element of last row. To the bottom of last element of last row. Okay. So this is called principal diagonal matrix. Okay. You have understood this now. So next we can go through diagonal matrix. Okay. Now let's go to principal diagonal matrix. Sorry, we have completed now principal diagonal matrix. Now we will go through diagonal matrix. So the diagonal matrix is a matrix which contains 0 except the diagonal elements. Okay, I'll show you that by an example. So a matrix which contains zeros except diagonal elements. A matrix which contains zeros except diagonal elements. So zeros except the diagonal elements. Okay, this is called diagonal matrix. Next we can go through scalar matrix. Scalar matrix is nothing but a matrix which contains zeros except the diagonal elements. Okay, but here one of the properties, the diagonal elements should be same. Okay, same. I'm mentioning here same. A matrix which contains zeros except the diagonal elements where the diagonal elements are equal. I'll show you example. 2 0 0 0 2 0 0 0 2 anything. Here you observe that the matrix contains zeros. These are all zeros except the diagonal elements. These are the diagonal elements, and one of the properties, the diagonal elements should be same. 2, all are 2. Okay. One thing I forgotten to say is the Diagonal matrix and scalar matrix have the order of the matrix is same. I mean square matrix, R equal to C, square matrix. Okay. So next we can go through identity matrix. So now we can go through identity matrix. Identity. I think so many times you learn identity, not identity matrix. One thing I'll say you is identity. What is identity is nothing but one. Okay. The meaning of identity is nothing but one, or else the meaning is same. Okay. So the identity matrix is the identity matrix contains zeros except the diagonal elements where the diagonal elements contains 1. Okay. Zeros except the diagonal elements where the diagonal elements contains 1. I'm writing in bracket. Okay. Some people will think that bracket, no, it's no need. It is important. Okay. Example 1 0 0 0 1 0 0 0 1. You can observe here except the diagonal elements 1. It contains zeros, but except the diagonal elements where it contains 1. Okay. This is identity matrix. Next, we can go through upper triangular matrix. So, the upper triangular matrix is nothing but a square matrix. Means the properties, it should be a square matrix where lower triangle contains zeros. Okay. A square matrix where lower triangular contains zeros. Example. First of all, they said that it should be a square matrix, right? I'll take one of the example. So this is the example. A square matrix in zeros. First of all, I'll say you what is lower triangle and upper triangle. Okay. Suppose if it contains here elements 8 0 0 5 8 3 1 2 4. See here. This is called upper triangle. This is called lower triangle. Okay. Here, if you observe here, a matrix, a square matrix where lower triangle contains zeros. Here the lower triangle contains zeros. So it is called as upper triangular matrix. But some people will be confused when the upper triangle matrix contains, they'll think that the upper triangle should be as zeros. No, it is wrong. So the upper triangular matrix contains lower triangle zeros. Okay. Mention that, keep it in your mind. So next we can go through lower triangular matrix. The upper triangular matrix is opposite to lower triangular matrix. By that you can understand what is lower triangular matrix. So now lower triangular matrix. So a lower triangular matrix contains where the upper triangular elements should be zeros. Upper triangular elements are zeros. Okay. You know what is upper triangle? For example, here, lower triangular matrix is nothing but a matrix where upper triangular matrix are zeros. So you know, this is upper triangular matrix. Now you say it is containing zeros. So lower triangular matrix is nothing but in which where upper triangular element contains zeros. So note down this. These are total of types of matrices. Totally there are 11. Next we can discuss trace. What is trace? Once you remember what is principal diagonal matrix. Trace. We can define trace only for square matrix. Okay. We can define trace only for square matrix. Okay, what is trace? To know about trace, I'll say you one of the best example. 1, 5, 8, 9, 10, 14, 2, 7, 9, 13, 8, 7, 6, 4, 3, 5, 11, 3, 2, 1, 1, 4, 6, 8, 2. So this is the example. This is the matrix of square matrix itself, but the order is, come on, see, that is 5 into 5. Okay, it is a 5 into 5 matrix. 5 into 5 matrix. Now here you can observe the elements 5. The row number is 5 and column is 5. So the what is trace means the sum of principal diagonal elements. What are principal diagonal elements? So once you refer through types of matrices in the principal diagonal matrix, once you refer that, you'll get to know what are principal diagonal elements. So the principal diagonal elements are, so these are principal diagonal elements. What I said here, what is trace? The sum of principal diagonal elements. Okay, sum. It means addition. So trace. We should note this trace as the symbol is TR. Okay, TR. So trace of this, suppose if you take it is a matrix. So trace of A is equal to 1 plus 2 plus 6 plus 2 plus 2. Okay. 1 plus 2 plus 6 plus 2 plus 2. So just I am adding the sum of the principal diagonal elements here. Okay. 1 plus 2 plus 6 plus 2 plus 2. So 2 plus 1, 3. 3 plus 6, 9. 9 plus 2, 11. 11 plus 2, 13. So the trace of matrix A is 13. So by this now you understood introduction of matrices, types of matrices, and order and trace. So I think so you have understood this. So if you like this video, please subscribe, share and like and tap the bell icon. So to receive all notifications. So I think so you have understood this. So thank you for giving this opportunity.